Good afternoon, viewers. Welcome back to Easy Mathematics. It's been a long time uploading a video, and we apologize for that due to technical challenges and problems. So we want more sponsors. We want you to help to sponsor this service so that all will benefit from it. And the last time we met, we were looking at two-set problem, that is Venn diagram. So today we want to finalize and look at two examples on the Venn diagram where we have no complement. And the next time we meet, we are going to talk or look at that one probably. So we have the first question here, which says, in a school of 100 students, 60 study biology and 55 study chemistry. Each student study at least one of the two subjects. A. Illustrate the information on a Venn diagram. Then how many students study I, both subjects, II, chemistry only? So once we've read the question, let's try to get the keywords here. Last week we were told that if we read through and we come across the phrase at least, it means there is no complement, which is the region IV. There is no complement. Good. So, because we are to illustrate the information on a Venn diagram, then we have to draw our data so that we define some of the words or things, elements we are going to use on the Venn diagram. So we have here our data. From the question, we have in a school of 100 students. So the total number of students in that particular school is 100, which is equivalent to the universal set. So we are going to say, let the number U be equal to universal set. From the question, the universal set is 100. That is the total number of students. Then when you look through, we have two subjects. We've mentioned two subjects in the question, which is biology and chemistry. So using our first letters to represent each, we'll say let the number C be equal to chemistry, and that of the number B be equal to biology. So when you read the question, it says that 60 study biology. So the number of students that study biology are 60. So biology, we have 60. And 55 study chemistry. So 55 studied chemistry. Definitely we are going to have both subjects, or the number of students that studied both subjects. So we have here the number C intersection B, which is both subjects. And since we do not know, or we don't know, we represent it with a variable, say A. Now with this data, we can draw our Venn diagram as the question is asking. That A, you have to illustrate the information on a Venn diagram. And we know how to draw a Venn diagram. We need two intersecting balls in a rectangle. Then we have here as our number of U, which is the universal set. The first circle here, let's say, is chemistry. And the second one is the number of biology. So since we don't have the third one, at least it's telling us that we don't have complement. So there's no need for us to create data for the complement. We just leave it here like this and we draw the Venn diagram. So from the question, we were told that 55 study chemistry. Because the question is saying that 55 study chemistry, and not only they studied chemistry, we are going to write the 55 up here. Same as biology, the question is saying that 60 study biology. So we are going to also position the 60 here. Now he says that the number of C intersection B, that is where the C and the B meet, is A. So we represent it with the variable A. So we have this as our first diagram. Now, since this 55 is the number of students that studied chemistry, drop this 55 in the region here. We were told that this region is region I, which is chemistry only. The whole region here, this region and this region, is for the chemistry. So if 55 studied chemistry, drop the chemistry, which is 55, inside and subtract the A, which means we are trying to remove the portion of A that is inside the circle, and that gives us the I only, which is the same as the chemistry only. Then also, since the biology stated there was 60 students studied biology, not only, we will also drop the 60 inside, then we subtract our A, which is the intersection. So this becomes chemistry only, which is the I, region I, and this is the intersection for both, which is the region II, and this is the region III, that is the biology only. And we have no complement because the question mentioned at least, or stated at least, telling us that there is no complement. So this is how we are to illustrate this information on a Venn diagram. Now when you continue, you have to find the number of students that study both subjects. So we are going to apply the ideas on Venn diagram, where we were told that these three regions without the complement is the same as the universal set. And even the universal set from the question, it is 100. So we have a complete diagram. So with this, we are going to do our addition by saying that region I plus region II plus region III is equal to the universal set. Or the number C plus the number B minus the intersection is equal to the universal set. So if I want to go by the regions, I am going to say that to calculate for BI, I am going to say that region I plus region II plus region III is equal to the universal set. Since the question has mentioned at least, there is no complement, which is the region IV becomes 0. So what do I have in region I? I have 55 minus A. Remember, we brought the 55 here because it is not only. So we brought it up here. If it was only, we will bring it here. So region I is 55 minus A plus region II is A plus region III is 60 minus A, which is equal to the universal set. From the question is 100. So now that we have an equation with variables at one side of the equal to sign, we simplify to get a value of A. So we have negative A, positive A. We say these two will cross out or will cancel out each other. Now we are having 55 plus 60 minus A is equal to 100. Then you simplify. This and this will give us 115 minus A. So this and this will give you 115 minus A is equal to 100. We group like terms. So we are going to say negative A is equal to 100 minus 115. If we subtract, we have negative A is equal to negative 15. Then what do? We divide both sides by negative 1 to get rid of the negative. So A is equal to 15. From our data, we said let the number of C intersection B, which is the region II, both subjects be A. So if we have been asked to calculate how many students study both subjects, and it is A, here we have A to be 15. So we are going to say, therefore, 15 students study both subjects. Therefore, 15 students study both subjects. then you have it there as your answer. So these 15 students, they studied chemistry. At the same time, they also studied biology. So we call them both. They studied both and they are intersection. So if you ask for biology, they are there. If you ask of chemistry, they are there because they studied both subjects. And when you come to the II, you have been asked to calculate chemistry only. Let me record that one here. II, chemistry only. And how can you calculate for the chemistry only? With the chemistry only, locate where the chemistry only is on the diagram. This circle is for chemistry and this is for biology. So 55 minus 8, this is region I, that is the chemistry only. So what do we have there? In the chemistry only, which is the region I, we have 55 minus A. What is A? From our solution, A is 15. So we are going to substitute it there. And this is going to give us 55 minus 15. 55. If you take away 15, you are left with 40. So this is equal to 40. So how many students studied chemistry only? We have here as 40 students. And this is what the question is demanding. Most of the times when you finish solving, you have to redraw the diagram. We have to redraw the diagram so that we will illustrate or represent them with their right values. So let me use this portion to redraw that. So we have here this as our number of U, universal set as 100, our first circle, second one. So we have this as number of C as 55, the number of B as 60. Then we have here as A. The A we solved for it at 15. So you write here 15. Then here is chemistry. So you drop it inside, then you subtract 15 from 55, just as we've done here. So 55 minus A is 40. Then when you come to this side, we did it here as 60 minus A. So 60 minus A is 15. So if you take 16 away from 15, you are left with 45. So this is going to give you 45. So you notice that if you add this region, you put them together, you are going to get the universal set there as 100. And this is how the Venn diagram is answered on such a question. This question has no complement, and it is easy for you to get the answer. You will notice that this plus this is 60, and plus this is 100, which is the universal set. And that's how we calculate for Venn diagram when there is no complement. Let's look at the last question on that for today. We have a question which says that a survey was conducted in Basic 6 and was noticed that 32 of them are good in football, 16 are good in only basketball, and 6 are good in both games. Each student is good in at least one of the two subjects. A. Represent the information on a Venn diagram. Calculate the number of students that are good in I. Only football. II. Basketball. C. How many students are in the class? So with this question that we've got through it, let's try to locate the key words there. Now when we read through, we saw a word like at least, which means no complement. Then we saw another word as only basketball. So you have to take good note of that. But with the football, it says that 32 of them are good in football. It didn't say only. So what do I need? I have to define my data for the set of questions. So we come here and write here data. To define, we can say let the number, let's say this, be equal to the universal set, also the same as universal set. Then we ask ourselves, what are the two games or subjects mentioned in the question? They've mentioned football and basketball. So the first letter, number F, should be football. And the number B should be basketball. Definitely, we are going to have students that are good in football and basketball. So automatically, we have to get the number F intersection B, which is both games. Both games. Good. Now let's take the question one after the other. Now we have our data. This will help you to draw a simple diagram without even going through the question to draw the diagram. So now we have our data. Let's come through the questions and provide the answers there. In a survey, was conducted in a basic 6 class. They didn't give us the number of students in the class. We don't know. So we can represent it with a variable. So let's say n. We don't know the universal set. And was noticed that 32 of them are good in football. So 32 of them are good in football, but not football only. So 32 are good in football. So that 32, we are going to record it as the number of F, which is number of football. When you continue, so 32 of them are good in football. 16 are good in only basketball. In only basketball. The question didn't say 16 of them are good in basketball. No, the question said 16 are good in only basketball. So we have to write the number B only is 16. Do not record the 16 here because the question said only. The one we record here is the people that did or played that game. So 16 are good in only football. So the number of students that are good in football, in only basketball, is 16. When you continue, and 6 are good in both games. So here, the question has made it clear to you that 6 students are good in both football and basketball. So the number F intersection B, which is both games, they are 6. So we record it there. Each student is good in at least, which means there is no complement because of the at least that has been stated clearly for us. So A represent the information on the Venn diagram. So now that we have this data, we can easily draw our diagram, our Venn diagram, knowing very well that we need a rectangular box, 2 circles intersecting, and we have the number here. We use this symbol as the universal, so we are going to use it. Then we have here the number F as the first circle, and the number B as the second circle. So coming back to the data, we said the number of students that are good in football, they are 32 in number, and not football only. So because they are 32 in number, we are going to record the 32 here. The number of football, which is this one, was not given. So since it wasn't given, we are not going to write anything here. Or we can choose to represent it with a variable, say x. Then we write here x. When you continue, the number F intersection B, which is the intersection, they are 6. So what do we record here? 6. And the number B only, which means for them they played only basketball. So because this is only, you just bring it straight forward to the only position of the basketball without subtracting. No, do not subtract. Because the question has made it clear for you that that 16 are good in basketball only. If the only wasn't there, we could have brought it here, just as we did for the football. So since the football wasn't football only, we brought it up here. But the basketball was stated clearly that 16 are good in only basketball. So we are going to record our 16 here. And this is how the diagram is going to be. So just as we did for the first one, drop this value inside, then you subtract the intersection so that you will get the region here, I, as the football only. So we have this 32, then you subtract the 16, the 6 out. Immediately we take out the 6, we are going to left with 26. That's 24. We are going to have 24. So we have here as 24 after subtracting. So this is the value we have here. So we have here as 28. 26. We have 26. Sorry, we apologize for that. So when you take 6 out of 32, you have 26. So this is what we have after subtracting the intersection from the football. So these 26 here are football only, but these 32 are the number of students that play football in all. So we've illustrated the information on a Venn diagram. The first question says, which is the B. So this is A. Now we have here as B. Calculate the number of students that are good in only football. So only football, that is region I. Only football, this region. So to calculate this region, which is only football, we are going to subtract the region I from the region. We are going to subtract this region I from region I. So we have region I minus, we are going to subtract this from the everything we have for football. How many students played football? They are what? 32. And that's the number of F as 32. So we are going to subtract region I. That is the number of F intersection B from this. So we say number of F minus the number of F intersection B. This is everything here, the number of people that did football. That's the whole of this circle. Then this is the region I, which is the 6. So 32 minus 6, as we calculated here, is 26. So therefore, we have here 26 students study only, 26 students are good in only football. So we have the B there, BR, only football. So we brought this one and we took away the intersection. We apologize for that. Then when you continue II, you have to calculate basketball. Now you should know the difference between basketball and basketball only. With a basketball, it means some of the students are in the basketball team and at the same time they are in the football team. But with the basketball only, they do not play football. It is only basketball that they are good in. So if I am to calculate the basketball, then I am going to add the region II to the region III to give me the number of what? B, which is the basketball. So with the II, we are going to say the number B is equal to region II plus region III. Remember that this region is both games. Played here, playing here. But the region III is only basketball. and you have been asked to calculate the students that are good or that are playing basketball. So 16 is playing basketball, and these 6, they are playing football, but also they are playing what? Basketball. So we are going to add 6 plus 16, and 6 plus 16 is going to give us 22. So 6 plus 16 is equal to 22. So we state our answer and say, therefore, 22 students are good in basketball. And we've stated our answer for the scores. And these are the students that are good in basketball. And with the last one, how many students are good in a class? How many students are in a class? So in all, you have to calculate the universal set, which we said we don't know. So what did we say to do to get the universal set? Region I plus II plus III is equal to universal set. So I have the number C as the region I plus II plus III is equal to the number of what? Universal sets. And what do we have at region I? Is 26, because this is football only. So 26 plus intersection 6 plus this we have here as 16 is equal to the universal set. So this plus this will give us 32. So if this plus this is giving us 32, then 32 plus 16 is going to give us 48. 32 plus 16 is giving us 48. So our answer here is 48. So what do we say? Therefore, 48 students are in the class. Full stop there. So we can choose to redraw our Venn diagram to illustrate the informations there. So we have 2 balls intersecting. We have the number of F, the number of B, and this is the universal set. As so number of F here is 32. Football, when we calculate them, basketball we have 22, intersection is 6. When you drop and we subtracted, we had 26. The only was given as 16. Then when we calculated the universal set, we had 48. And you will notice that this plus this will give you the universal set. So this is a Venn diagram without complement. Without complement. The next time we'll meet, we will look at how to calculate or solve for a Venn diagram question with a complement. Thank you for staying tuned. God bless you. This is Easy Mathematics. Please don't forget to hit the subscription button, and please, we want sponsors so that we'll be able to drop more on that. And all those that have requested for Venn diagram, graph, VAT, construction, we are working hard on that. If God permits, we'll give it to you before we write our end or our final exams in this year. Just stay connected, and I hope we'll get to do something and get some questions, likely questions that we'll be solving here that will come in our final exams. See you, God willing, next time. Bye-bye.